Hello and welcome to another video brought to you by RouTube. In today's video, we're going to be learning how to solve linear equations, which students will encounter in both Year 7 and Year 8. Now, it's important to note that you'll be solving linear equations all the way through high school, so it's really important to get a really base understanding, which hopefully you will get from this video. Alright, so two really simple learning objectives for today's lesson. The first one is to solve one-step linear equations, and the second one is to solve two-step linear equations. Alright, so before we start solving equations, I think it's really important to understand what the word solve means in maths. Okay, so solve means to find the value of the unknown. Okay, so the unknown being the variable or the pronumeral, which is just the unknown letter in maths. So the variable or the pronumeral is the same as saying a letter. Okay, so let's have a look. Solve the following one-step equations by doing the same to both sides. Okay, so it's really important, when it says both sides, the equal sign is almost your marker or your guide, and then anything to the left is one side and anything to the right is the other. So you need to make sure whatever you do to the left-hand side, you always do the same to the right-hand side. So let's have a look at question A. X plus 5 equals 11. Okay, and the reason why it's called a one-step equation is because there is only one thing that is currently happening to X. Okay, and hopefully you can identify that X is currently being, or 5 is being added to X. So we've got X plus 5 equals 11. So our main objective is to find the value of X. Now some of you might be able to look at that and sort of work a little bit backwards and try and work it out sort of in your head, but we need to have a proper process when we're solving. Okay, because then when we get to the really the more difficult questions, which we'll go through later in the video, you really need to make sure that the process is all under control. So here we have X plus 5 equals 11. So hopefully you've been introduced to what we call the inverse operations. So the inverse operations are just the opposite operations. So addition and subtraction and multiplication and division. So here we currently have addition. So we've got X plus 5. So what we need to do is we want to get rid of that plus 5 on the left-hand side. So what we're going to do, we're going to use the inverse operation, which is to subtract 5, but we must do the same to both sides. We must always do the same to both sides. And now what we can see is on the left-hand side, what I might do is I might highlight the equal sign so we can clearly see left-hand side and right-hand side. So now hopefully what we can see is on the left-hand side, we had positive 5 and we've taken away 5. So essentially they can just cancel out. So what we're left with on the left-hand side is just X, which is what we wanted. We want to isolate X and get it on its own, which is the objective of the question. So here we have X equals, and then we have 11. Don't forget to subtract the 5 because you subtracted the 5 from that side. And then we have 11 minus 5 should give you 6. Okay, so like I said before, you might have sort of been able to work out mathematically what plus 5 equals 11, but this is the really important method in using the inverse operations and doing the same thing to both sides. That's the most important. Let's move on to question B. So again, it's a one-step equation because there's only one operation that is happening, or one thing that is happening to our variable, which is y. Okay, and that is multiplication. So we've got 2y equals 8. So essentially what number, when you multiply it by 2, will give you 8. All right, you might be able to work out the answer already, but we need to use the correct process again. So we've got 2y equals 8. I'm just going to rewrite here 2y equals 8. Okay. Now, because the 2 is multiplying the y, if you've got a number which is called the coefficient in front of the variable y, you need to know that in between the coefficient and the variable is a multiplication sign. Okay, so we then use our inverse operation. So the inverse operation of multiplication is division. So we're going to divide both sides by 2 to get rid of that 2 to then isolate the y on its own, which once again is the objective of the question. So then now if we have on the left hand side, and I'll again highlight the yellow, on the left hand side we've got 2 divided by 2. Okay, so they've once again just undone one another, so we can just cancel out the 2 on the top and the 2 on the bottom, because 2 divided by 2 just gives you 1. So then now on the left hand side of the equation, all we're left with is y, And then on the right-hand side of the equation, you're left with 8 divided by 2. So 8 has how many 2's? Should be 4. And hopefully that was the answer that you all got, or you were all thinking when you first saw the question. So inverse operations and making sure you're doing the same thing to both sides are the most important things for these couple of examples. All right, now let's have a go at solving two-step equations. Now these ones will look different to the previous ones because they are two-step instead of one-step. Hopefully you'll be able to see that there are two operations or two things that are happening to our variable. In the first question it's p, and in the second question it is g. So solve the following two-step equations by doing the same to both sides. So same process as before, we're just going to have two steps instead of one step to do. So again, I'm going to highlight the equal sign on both questions just so we can distinguish between left-hand side and right-hand side. So the left-hand side says 2p plus 6, and then the right-hand side we've got 12. So 2p plus 6 equals 12. Now, what we also need to remember when we are solving two-step equations, there's a specific order in which we need to solve the equations. Okay, we can't just solve them in any order. We need to work in a specific order. Okay, now what are the two operations that are present in this question? Well, 2p means that 2 is multiplying by p, and then we've got the plus 6. So we've got multiplication and addition. Now what we need to do when we're solving, we need to work in reverse BIDMAS order. Okay, we need to work in reverse BIDMAS order. Okay, so we need to start with subtraction and then move to addition and then multiplication, division, indices, and then our brackets. Okay, so let's start with the S. Is there any subtraction in this question? Well, no. Is there any A? So addition, yes there is. We've got the plus 6. So we need to start there before we do anything with the 2. So what we do is we then subtract 6 from both sides, like we did previously. And then on the left-hand side, we've got our positive 6 and our negative 6. That can cancel out because 6 minus 6 just gives you 0. So then on the left-hand side, we're just left with 2p. And then on the right-hand side of the equation, we're just left with 12 minus 6 gives us 6. And then now your question becomes a one-step equation because now there's only one operation or one thing happening to our variable, which is p, which is multiplication. So now what we can do is, this one's similar, very similar to the previous one, where we've got 2p equals 6, and then what we're going to do is we've got multiplication, so we use the inverse operation, which is division. So we're going to divide both sides by 2, which is then going to cancel out both the 2's on the left side of the equation, which then leaves us with p, and then on the right side we just do 6 divided by 2, which should give us 3. And then a really good way to check your answer is, let's substitute the answer back into the question, okay, which we'll do in a different color. So we're going to rewrite the question. We've got 2 multiplied by 3 because I'm going to replace the p with the 3, and then plus 6 equals 12. And then let's see if the left-hand side and the right-hand side are equal. And if they are, then we are correct. So then we've got 2 times 3 equals 6, and then 6 plus 6 equals 12, which it does. So therefore, we have substituted correctly, which means we have solved correctly. Moving on to part B. So now we have 4g minus 7 equals 17. Okay, so now we have two operations again. We need to work out the specific order. Remember, reverse BIDMAS when we are solving. So we start with subtraction. Do we have any subtraction? Yes, we do. We have subtraction present in this question. So we are going to use the inverse, which is to add 7 to both sides, which is then going to cancel out the 7's, which is then going to leave 4g on this side of the equation, on the left side. And then on the right side, we've got 17 plus 7. Don't forget to add your plus 7, or sorry, to add your 7. So we've got 4g equals 24, which is quite similar to the previous example. but just with different numbers. So then now we've got 4g equals 24. And now because we've got multiplication, it's 4 times g, we're going to use the inverse, which is to divide. So we're going to divide both sides of the equation by 4, which is then going to cancel out the 4's on the left. So on the left, we're just left with g, and g equals 24 divided by 4 should hopefully be 6. And again, now to double check our answer, we'll do that again. So wherever we see g, we're going to take it out and replace it and substitute it with 6. So here we've got 4 multiplied by g, which is now 6, minus 7 equals 24. And then hopefully the left-hand side and the right-hand side match or are equal. So we've got 4 times 6, which is 24. We've got 24 minus 7 equals, and now I've written 24, which should be, this should be 17, not 24, that should be 17. So 24 minus 7 does equal 17. So we've substituted correctly and we've solved correctly. So that's a good way. That blue part down the bottom is just a good way to double check and make sure that you have solved correctly. All right, let's solve a couple more two-step equations. So you have a look at A and B look really, really similar. Okay, they've got the same variable, they've got the same signs, got the same number on the denominator and the same value on the right hand side, but they are a little bit different. Okay, so the process needs to be a little bit different and we're going to go through it now. So solve the following two-step equations by doing the same to both sides. So we're going to follow the same process that we just did, and again I will color the equal sign so we can distinguish left-hand side from right-hand side. So hopefully you'll be able to identify, we've got q divided by 3 minus 3 equals 12. Okay, so that q over 3 minus 3, that's the left-hand side. So that subtraction of 3 is subtracting the whole q over 3. Okay, so that's not attached to the q like it is in part B. So what we need to do for this question is we need to use the inverse operation and get rid of that subtracting 3. So we use the inverse. Remember, we're working in reverse BIDMAS order. That's why I'm getting rid of the subtraction before I get rid of the division, because we're working in reverse BIDMAS order. So we're going to get rid of the subtraction before we worry about the fraction. So we're going to add 3, use the inverse on both sides, which is going to get rid of the positive 3 and negative 3. Which means on the left side, we're just left with q over 3 equals 12 plus 3, which is 15. Now what we need to do? Well, now we need to see what's actually happening to our variable now, and we should hopefully see that it's being divided by. Okay, so it's been divided by 3. So now what we do is, we can just rewrite it again. We've got q over 3 equals 15. Now the opposite or the inverse operation of division is multiplication. Okay, so now because the 3 is on the bottom of the fraction, we're going to multiply the left hand side by 3 and the right hand side by 3. Now if you're not sure why I used brackets, that just means multiplication. Okay, so I could have used a multiplication sign as well and that would have been okay. On the left hand side, the 3's can cancel out. So the left hand side, we're just left with q. And on the right hand side, we're now left with 45. Again, substitute the answer back into the question to make sure that we have solved correctly. So now we've got 45 over 3 minus 3 equals 12. So 45 divided by 3 should give us 15, and 15 minus 3 does give us 12. So correct and correct. Once again, the blue is just you checking to make sure that your work is correct. Now, part B. Now you'll see the difference. The negative 3 now belongs to the q. Okay, so it's right next to the q, and it's on top of the 3. Okay, so now what we need to do, we've got subtraction and we've got division. But what we need to do, we need to get rid of the fraction first. Okay, we need to get rid of that dividing by 3 first. So we need to work in a different order. Okay, so I'm just going to rewrite what we have here. We've got q minus 3 over 3 equals 12. So to get rid of that, now we're going to work in the reverse order. We're going to multiply by 3 and multiply by 3, which is then going to get rid of the fraction because the 3's can cancel out. So now we're just left with q minus 3 equals, and then we've got 12 times 3, which is 36. And then now we've got a one-step equation, so we use our inverse operation, which is to add 3 to both sides, add 3 to both sides, and then we can cancel these 3's, which becomes q equals 39. Now again, let's check our answer. So we're going to redo substituting the value for q. So we've now got 39 minus 3 over 3 equals 12. And let's see if it is correct. So the top of the fraction, the numerator, 39 minus 3 gives us 36. And 36 over 3, or 36 divided by 3, does it equal 12? Well, yes, it does. We can give ourselves a tick. We can give ourselves a tick. So we have solved correctly. All right, and let's finish the video off with one last two-step equation. Now this one's a little bit different because we've got some brackets, okay? Now there's two different ways we can do this question. We can solve a question like this, okay? And I'm going to show you both ways. Both are totally fine. One might be a little bit new to you, especially if you're in year 7, because you wouldn't have learnt about expanding yet, okay? If you're in year 8 and you haven't learned about expanding yet, you will learn about it at some stage throughout year 8. So the first way, what we're going to do, let's have a look. 3 and then in brackets y plus 2 equals 18. So we're solving for the value of y. So what we need to know is between the 3 and the opening of the bracket, there is a multiplication sign. So there's a little multiplication sign in there in red. Okay, so 3 is multiplying everything inside the bracket. So we're just going to rewrite that. So 3 and then y plus 2 equals 18, and let's close our bracket. Now, what's happening to the variable? Well, the variable is being multiplied by 3 as well as the positive 2. So the 3 is multiplying everything inside the bracket. So let's try and get rid of the brackets first. Okay, so let's do our inverse operations, which is to divide by 3 to both sides. As always, we divide by 3. Now on the left hand side, and what I might do is, again, I'll highlight these, and on the left hand side we can cancel out our 3's, okay, which is what we wanted. So now we're just left with y plus 2 on the left hand side, and then we've now got 18 divided by 3 should be 6. Okay, and now we should be all okay from here because it's now just a one-step equation. So we've now got subtracting 2 and then subtracting 2. So then now on the left-hand side, we can cancel out our positive and negative 2 to give us y equals 6 minus 2, which gives us 4. Once again, let's substitute and see if our answer looks all okay. We've now got 3, and then in the brackets, instead of y, it's now 4. 4 plus 2 equals 18. Well, let's check it out. Here we've got 3, and then multiply by 4 times 2 is 6, equals 18. So essentially, does 3 times 6 equal 18? Yes, it does. So the left-hand side and the right-hand side do match. And now let's solve using a different method. So like I said before, if you've been introduced to expanding, this method will hopefully make some sense to you. If you haven't, that's totally okay. You can use the first method and you should always get the same answer. Doesn't matter which method you use. So I'm just going to rewrite the question out again. So we've got 3 and then y plus 2 equals 18. Now if you're not familiar with expanding, I have also created an expanding video. So check out the video if you need some assistance on expanding. So on expanding, we're going to multiply whatever's outside the bracket with both terms inside the bracket. So the first thing we're going to do is we've got 3 times y to give us 3y, and then we're going to do 3 times positive 2 to give us positive 6, which equals 18. And now we have a two-step equation without brackets. So that's expanding. Now we can subtract 6 because we're working in reverse BidMass order. So then now we can cross out those two. We've now got 3y equals 18 minus 6 gives us 12. And then now we can do our final step, which is to divide by 3, which will isolate and solve to find our value of y, which is 4. Now you'll see we get the same answer doing both methods, whether we work through our normal solving method or we work through expanding first and then solving. You'll always get the same answer, so it does not matter which one you use. Thanks so much for once again watching another video brought to you by RouTube. If you want to request a specific video, please leave it in the comments below. And as always, please feel free to subscribe to my channel. I'm going to continue to work and produce some more videos from Year 7 Maths all the way up to Year 12. Thank you once again.